my name is Kevin. Today I'll be giving a quick tutorial on how to run a basic regression on STATA. A regression analysis will basically tell us how correlated two variables are with each other in the data set. This can be a useful tool for policy analysis and epidemiology for trying to identify what factors are most influential to a result. We can observe phenomena such as cigarette sales versus taxes and what effects does per capita income have on housing prices. STATA is the tool we use to find these relationships and can tell us if these relationships are statistically significant. For today's tutorial, we will be asking the question of does taxing cigarettes cause a statistically significant decrease to per capita pack consumption using data sets taken from the ideas page. So to start, you're going to want to open up STATA, and immediately up to the top left there is the help tab. Go down the help tab to check for updates. What this does is it sends a message to the server asking if there are any updates to STATA. There is a new update, but for the sake of this video I will not be updating. And that's going to be the first step. Once you check for updates, you're going to want to get acclimated to the program. So in the center console, we have the screen that has the outputs. So whatever you put into the command window, which is right here, will be output here. The command window is where you type in all of your commands. On the right, we have the variable screen, which will tell you all the variables you have loaded from a data set, and the properties of those variables are seen here. Over to the left, you have the history. So we can see that the first command I typed in was the update query command, and it shows up in the history. To get started, we need to get a dataset. Datasets can be found all over the internet, especially on university websites and government agencies such as the National Bureau of Economic Research, NBER, and the Medical Expenditure Panel Survey, MEPS. Simply download the data file onto your computer and save it to any location you'd like. For this example, we will be using cigarette taxes from 1985 to 1995, which are stored on the IDEAS website here. A link to this will be available in the description. Once you've downloaded the dataset, go ahead and save it to your desktop. So over here I have it saved into my upper left desktop. We're going to want to use the use command. So under here in the command window, we type use, and then we type the file name. So basically the file location is where all of this is saved. So here we have our desktop. So we go to use, C, users, your username, desktop, /sig data 85 95. If that's that, nope. Sig 85 95. So now we can see that all of our variables have been loaded into the right side of the screen. So that means that STATA successfully read all the data and has imported it into the system. If the opening was successful, you should see the variables window fill up with all the variables in the dataset. If something went wrong, for example, you misspelled the dataset or file location, STATA will highlight your command in red and will inform you that an error has occurred and will include an error code for you to troubleshoot that error. So let's say I try to type this again. We do copy, paste, but I take off some parts of that. Then we get a red error code telling us that the command wasn't successful because it couldn't find the file using this location. And we have the error code here. We can click on it and it'll tell you exactly what happened. The file name you specified cannot be found. So let's say we want to get some basic summary statistics of our variables. To do that, we can use the sum command. So we type sum. Then we type our dependent variable, which is pack PC, and then we type our independent variable, which is the tax. What this will do is it'll pull up your mean values and your standard deviations. So we know that the mean packs per capita consumed was 106 throughout 1985 to 1995, and there's a standard deviation on there with a minimum and a maximum. So now that we have summary statistics, we can run the regression at this point. So what summary statistics doesn't allow us to see is the relationship between the two variables. It just shows us the basic statistics of those two variables. So we can actually type regress. You can also shorten this down to reg too. This will only work for commands that don't have the same first three letters as other commands. So we can type reg pax, pack PC text. And what this has given us now is a regression table of all the results that we need to try to interpret the data. So now we want to do the actual regression. So to do the regression, we can just go ahead and type regress. Or if you like, we can also just type reg This will work for any command which does not have the same first three letters as any other command. So we could type reg, pack PC, tax, and now we have our regression table results. So now that we've actually run the regression, we need to actually interpret the results. So to interpret the results, we have an R-squared score, t-scores, and regression coefficients. These are basic components of the regression that we need to look at to come to some sort of a conclusion when it comes to an economic interpretation of the variables. So the R-squared score will simply tell us how well does the data fit. So how well does tax data fit with tax per capita data? We have a 32% correlation there. So this is it's not bad, but it's not good. We can't really get much from this. It does tell us that there is some sort of correlation though between the 2 points. Here in the coefficient we have a negative 1.06 coefficient, so this will tell us that the line is downward sloping. So it tells us that as taxes increase, the slope on that line will go down. So as taxes increase, tax per capita also decreases as well. Here we have our t-score. So usually if you run a 95% confidence interval test, so you want to be 95% certain that the data is exactly how you expect it, it should be below 1.96. In terms of absolute value, this is greater than 1.96 in absolute value. So because this t-score is so high, we know that there probably isn't a statistically significant result that we can take from this regression. So let's say you want to look at the graph as well. So you have the regression table, but you also want to look at the graph of the data. To do that, we use the graph command. And because we have two variables here, we use the two-way modifier to that command. Now let's say we want to have a graph that has the line of best fit on it with the confidence interval attached and also has the scatter. So then we type comma, lfit ci, your dependent variable, pack PC, and then independent tax, then another comma, scatter, dependent variable, independent variable, hit enter, and now we have a graph, and now we can actually see what the data is doing. So we can already see that our best fitted line doesn't really do a great job of modeling the graph. As a matter of fact, we have a lot of scattering all around the area. However, we can definitely identify that there is a negative relationship here, that as average taxes increase during a fiscal year, we can see that the amount of packs consumed also drops as well. So this graph gives us important insight into the actual relationship instead of just staring at the numbers. So now that you have the basic regression results, you have the graph, then congratulations, you now have enough information to make a relatively accurate interpretation of the relationship between the two variables. While that's not an entirely true statement, and while these results don't necessarily explain the whole relationship between taxes and packs consumed, it'll be able to give you a basic idea of the implications within a relationship, and it'll tell you whether two variables are correlated in the slightest. Statistical errors in the data, such as bias and variance, can cause issues with the analysis, but that's reserved for higher level econometricians and data analysts. So like one of the biggest issues is, because we're looking at data from all 48 states, we know that tobacco states will behave differently, because if a state tax is imposed in a tobacco state, but cigarettes are already so cheap because it's in a tobacco state, then it probably won't be as significant as, let's say, if you're in Wyoming and a pack of cigarettes goes up by $2, that might actually have bigger influences on the data than a tobacco state would. But as I said, these biases and errors are reserved for higher level data analytics and statistics. And as for any troubleshooting, if any issues ever come up in the middle of trying to get a regression going, or just trying to get a regression going, or the graph isn't created correctly, so let's say I type graph two-way alfit ci, and let's say I want to do pack PC, but I misspelled tax. it'll tell us that this is an ambiguous abbreviation, that it couldn't find this variable because of a misspelling or another issue. Anytime an issue occurs, Stata will always put in your history that you have a red command, which means that Stata could not run the command, and it'll give you the error code for it as well.